Thank you everybody for coming out in the afternoon on essentially day one of Summit. My name is Scott Haines. I'm a staff developer advocate working for Databricks. And then we got Jazz as well, if you want to introduce yourself.
So I'm Jazz Koo, a solution architect at PuppyGraph, and we'll be talking about graphs obviously later on, so very excited.
Awesome. So I'm going to kind of kick things off. So is it coming through? Okay, awesome. Okay, perfect. This is good. All right, so who here deals with governance? Who here deals with like lineage in general? Probably most people in like the audience as well. Who here works with like open source? Okay, awesome. This is wonderful as well. So what we're going to talk about today is essentially like what you can do like with open source, and then what you can do to essentially kind of tack on like a graph on top of that as well. So if we think about like lineage a lot of times has been essentially, you know, a line over time. Now with like most modern systems, things are becoming more graph-like, and especially like with agents, things now essentially don't necessarily meet the old mold of essentially like A to B to C to D. Everything's more graph-like in terms of that structure as well. And so if we think about it, we went from essentially tables, where we had tables, we had relationships, we had an upstream and a downstream dependency. A lot of people have probably dealt with things where you don't necessarily have just an upstream and a downstream, you're kind of central nodes where a lot of people are pulling data from those individual nodes as well. So you have to understand exactly like what the relationships are between what data you're providing, what data people need, and then also like the governance and policies on top of all that as well. So in theory, right, we are going from a line to more of an n-dimensional graph as well. And so if we think about that as well, right, relationships are really, it's like a first-class citizen now between, you know, us as producers of data, other people as consumers of data, and also now like agents as well in the mix. And so we want people to be able to actually, you know, quickly traverse the lineage to understand how data flows through a complex network. And we also want to be able to ensure that, you know, any kind of change that might affect, you know, thousands, hundreds of thousands, many like very important like downstreams, and downstreams being plural nowadays as well, but that's not going to necessarily be something that we break by accident. And so lineage now is a lot more important. Like it was important before, but I feel like over the past like few years, it's become something that people just can't really live without. And so with that as kind of a setup, we're now going to start talking about how we emit lineage. And then that's going to be kind of part one of this talk as well. And then in part two, we're going to talk about how we actually query that lineage. And Jazz is going to go into Cypher queries as well. And what does it look like to be able to query things that are n-dimensional as well. All right, so if we think about emission of lineage as a source. Who here is a Databricks customer? Okay, awesome. So you've probably already used Unity Catalog. You have auto-lineage. It's something that just kind of comes for free. For people who aren't a Databricks customer, lineage is something that is probably tacked on, and it's either done essentially upfront. It might change over time, but you really want lineage to be something that's actually a part of your pipelines that is essentially always updating and keeping like the state of your graph intact. So, who here has heard of OpenLineage? Awesome, a few hands, this is great. So OpenLineage is a specification that talks about how we emit things that occur. How do we emit events? Say I run a job. I now have essentially I've got an event that keeps track of that job that produces data. If I have specific other events that I need to emit as well, there's actually like an open standard. It's all OpenAPI. So an OpenAPI specification tells me how I can actually emit my lineage, so that can be received by a server that can then essentially create the ground for us to be able to parse that as an actual graph and a relationship within a large network as well. So OpenLineage is a specification. It's also a JSON specification. The project we're talking about today that's also open source, all it does is add a gRPC layer on top of that as well. So you can essentially emit the gRPC data from any of your sources, which is kind of cool. And so if you don't know about gRPC, that's okay. You can take a look at the actual project as well at the very end of our talk. And then you can use it. It's free to use. And it also comes with like agent skills, so you don't have to worry about really how it works. You can just start to use it, which is really cool. So OpenLineage, we get run level events, column level lineage, and essentially you can emit that directly from like an engine like Spark. You can also emit that from within your Data Fusion Scan Plan API plan behind the scenes, or you can essentially just track this as an API. So if you're creating a data platform, or if you work in a data platform group within your company, then you can just hit the API if you want to do something that doesn't require an engine to be in place. So there's many different kind of ways of operating within this whole entire graphical interface. And essentially it's all just OpenAPI specifications, which is really cool. And so given that we don't have a ton of time to talk about everything today, I'm going to kind of just quickly go over the bare essentials. So if I have different events that I need to emit, and I don't want those events to break over time, in the same way that I don't want my lineage to fall apart over time, I need something that I know I can actually depend upon that has backwards and forwards compatibility. And that's essentially where Protobuf and gRPC comes into play. Protobuf essentially defines how I change my schemas over time, which is very important, especially if you're keeping track of an n-dimensional relationship between lineage within your actual data networks. And so with a lot of this, we create messages, which is really no different than the way that we think about JSON, only we do it in a format that is essentially type safe. We can compile it down, and it's reliable. So what we have on the screen right now shows what a service is, and a service can be compiled down to your language of choice. That could be Rust, it could be Go, doesn't really matter. There's compilers for all of that. All we're doing is emitting events, and we don't have to actually think about, well, we only have a JavaScript API from the front end. We only have a Scala API from the back end. Now you can essentially just emit events from anywhere where you can produce a message, and then that ends up becoming something that is then ingestible into your actual graph as well. So from a Spark job, who here is familiar with Spark? Good. That's a lot of good hands. It is a Spark. Spark is definitely something that we talk about at Data Summit. So with that in mind, Spark has plugins. And so the official open source, OpenLineage plugin for Spark, just a plugin, you add it, it will automatically read all of your any kind of plan. So if you have a data frame and you call any sort of action on it, it's essentially creating an unresolved logical plan, which then gets resolved, and then you have a finite action, which might be I'm going to go write this data to Iceberg or to Delta Lake. With all of that behind the scenes, all the OpenLineage plugin does is it reads through the whole entire plan. It understands upstream sources, it understands downstream sinks, and it creates essentially your relationship for a job that's being run, which is great. We don't have to go into much more detail on that right now as well, but that's the whole reason for OpenAI, or not OpenAI, sorry, OpenAPI. It's okay, it's also an AI event, so it's all good. And so anyways, there's a Spark plugin, you put into Spark, you run your jobs, you don't really think about it. As long as there's a service running that can accept your emitted gRPC payloads, which is Protobuf, you're good to go. The way that we set this up was essentially a Go ingest service, because I like Go. I also like ConnectRPC, because I used to work at a company called Buff. We created ConnectRPC and gave it to the CNCF. I also like Rust as well. Rust had a lot more capabilities for Iceberg. It had a lot more capabilities for Delta Lake than just Go itself, because Go doesn't necessarily have its own data frame APIs. And so Rust sidecar is all part of this architecture. But with that said, we can always talk more afterwards. And now I'm going to kick it over to Jazz.
Yep, perfect. So I hope you can hear me. So Scott very nicely went over basically how we're trying to collect and ingest that data. And so now that we have all of it very nicely in our tables, we are going to query it as a graph. This is against conventional wisdom to query your tables in SQL. And I'm going to make you raise your hand one more time. How many of you have queried in Cypher or Gremlin or know what those languages are? There are some hands. I expected none. I'm very surprised. This is amazing. Let's go. And so before we kind of talk into how exactly we're going to query it as a graph, let's kind of go into why we would want to query it as a graph. And so the thing is that once we have all our lineage emitted and piled up into the tables, you really start to care about the relationship between the entities in your tables, right? For example, which AI models were trained on data derived from this now revoked source. The issue is that you have data sets that are derived from other data sets. Your AI models touch tons of different data. And so it's not always very clear cut where that information is coming from. It's not a single 1 to 2 hop query. It can span out to 6 or 7 transformations. So this is very graph shaped. if this table fails compliance, what else is affected, right? What is the downstream blast radius? And hey, maybe agents are reading PII that it shouldn't be given access to. What jobs happened along the way, and why does it look like that, right? You care about who owns the assets across teams and catalogs, and kind of what they're using it for, right? I went too far. So one other interesting thing is that if graphs are so helpful, why aren't people using it more? The big thing is that people have tried, but usually, traditionally, it requires standing up a separate graph database, which means that you have to stand up a whole nother database before you can test out the value of graph queries. And that's kind of where PuppyGraph comes in today as a zero ETL graph query engine. So you actually point at your existing lineage tables that have come from Scott's half. Then you tell us which tables you want modeled as nodes and edges, and then you can start querying it like a graph as is, which is very convenient. You don't have to stand up a separate graph database. You don't have to copy any of your data over. We're connecting directly to the underlying tables. And so this means that you, instead of writing your scrolls and scrolls of SQL, your complex table joins, you can really just write a graph traversal in Gremlin or Cypher. And one really interesting thing is that we're not kind of converting graphs into SQL. We are actually handling those traversals on PuppyGraph's end, so you still avoid the penalty of these table joins. What this means for you is that you still get the interactive speed required to answer your governance questions. And we also have a distributed graph query engine that leverages vectorized evaluation and an MPP architecture in order to ensure that you get your graph responses in seconds to sub-seconds. Another really interesting side effect of this of this zero ETL approach is that we can actually run federated graph queries very easily. For example, this data set kind of collects data lineage, but if you want to access your access policies and identities, and they're all in different sources, you just need to point to those catalogs, and then you can have one graph traversal to query them all, I guess. And so I don't have enough time for a real demo over here, so I've taken screenshots from the PuppyGraph UI. But basically, because you're not really certain of how many inputs and outputs a job will produce, OpenLineage actually kind of has them as little JSON. So we're going to flatten the logs first. And then you can see that we have three types, which is job inputs, and job outputs. And one really interesting, I need to stop saying interesting, but one really cool thing is that the same table can be both a node and an edge, right? For example, for job inputs, it tells you, hey, what data sets were used in the job, but also what direction it's going in, right? It's getting consumed by a job. And then the job output is not only a data set, but it's also produced by that job. So over on the right, you get this really nice kind of circular thing going on. So that's kind of how the PuppyGraph schema looks like. And then from there, you can immediately start running your graph queries. So one query, any number of hops, and you can also collect every intermediate job and its downstream inputs. So if you're not familiar with Cypher, this is a very simple Cypher query. So what I'm doing over here is saying, hey, in my path, I want to make sure that I start with the data set and I end with the data set. And I kind of want to trace the path along it, what was consuming these data sets and what was produced by it, and then return me that path, right? And so over here, it's a really simple example. I think it all kind of just filtered into this one mega job. But if you can imagine like how complex it can get as you get more paths and more data and more jobs running. And so, yeah. Graphs are cool, amazing. And then in this pipeline, we've kind of shown you like this end-to-end lineage architecture where you really just have to think, once you emit and transport that lineage, it all goes into your tables. And because of that, you're actually able to kind of run your SQL queries alongside of your graph queries if you wanted to, because PuppyGraph can sit on top of those tables and you're able to query it straight out, right? So it kind of makes it very queryable. And why is this the future of AI governance? If you think about it, AI is always super unpredictable, and it's bringing rapid challenges, and you're kind of wrapping your head around, hey, am I giving my AI the right information, the right permissions and everything? And so when you are able to trace any model output back to its source data and policies that govern it, it really provides you a lot more clarity into understanding how your AI is functioning, where it's getting its information from. And so this also ties back to this cross-axis accountability, where you're no longer caring about, okay, this is the output, right? You're actually trying to trace through and see what exactly they touched. And these model quite nicely as a graph. You have your data, your model, your policies, and owners that are all entities, and then the edges explicitly show how they relate to one another. And so this lets you answer questions like real-time blast radius. For example, if you revoke a source, you kind of want to see which AI agents are affected, what prompts you might need to change. And then one of the big things for us is that it is kind of open, not locked in, because you have OpenLineage definitions, so you know exactly how the data is going to look. You can use ConnectRPC to kind of just communicate. And then once you have all your data in these tables in their open table formats, you're kind of able to use your compute engine of choice based off of the workloads you need. So for your regular aggregation queries, you can continue to use SQL. And then once you need to enter that mode for those deeper investigations, for those path tracings, then you can query in place with PuppyGraph, so you don't have to stand up a separate graph database. You're not locked into a specialized graph solution, right? And so I guess the main takeaways here is emit it openly, query it as a graph. Once you are able to capture the relationships, being able to query it and get your answers in real time become very important, and it really provides a lot more value to the data that you're kind of shoving all into your data sets, right? Yeah. All right, then.
Awesome.
Thank you.
Cool. So the last one was essentially just a last-minute slide. It's not pretty. If you want to test out everything, this whole entire environment gives you everything to do that. It provides all the Protobuf, provides everything you need, pre-compiled as well. So you just have to run it, and that's pretty much it. So with that, I know we can't take questions because there's no microphone that I think we can share. But thank you so much for coming out to this. Thank you for coming on day one as well, and I hope the rest of Summit is good. So thank you.
Thank you.